Hi, thank you so much for having us. And so Jen and I worked together on the East Bayfront Toronto project, which Jen will be talking about. And that's how we met and became friends over the project. And just further to Anne's point, and talking to Tony before the lecture started, it was really the larger team that really made all of the both projects that we're going to be talking about, that it wasn't just one discipline that kind of led the way, and it was how we spoke to each other, and often, well, similar to like the design studio and kind of this iterative process of, going over design and kind of rehashing it, that really brought out the right solution for the project. So everything we learned in studio kind of came full circle with these projects. I just also wanted to mention that I grew up in Galt, and I lived at Tate and Gordon, and Gordon's a bit of a steep hill. And my sister and I, when we grew up, my mom used to let us play in the water that came down the street in a heavy rainfall. And over time, the city of Cambridge allowed further development up the street. And so we would watch all the mud and the construction debris kind of come down the street and block up the sewers and create localized flooding. And so we kind of played around there. And then after the development was done, even more water came down the street and would cause flooding on a regular basis. And so we kind of got to play around a bit. And that kind of struck me as a child, and it was super fun. And another thing that struck me that sort of ties into this presentation is our neighbors would often very carefully try to pour paint down the storm catch basins. And, they didn't want to make any marks on the grill, and they just wanted to get rid of their paint so that they could throw out their cans. And I asked Joe, one of the neighbors, like, "What are you doing?" And he said, "Well, I need to get rid of this paint." And I kind of thought about it, and he's like, "Don't worry, the city cleans the water, it's fine." And so this all kind of got wrapped up back into what we're going to be talking about. So when we talk about stormwater and when we think about rain, really what we're talking about is precipitation. It's anything that falls from the sky, whether it be rain or sleet or snow, and really that becomes stormwater. So when we think about an urban situation, the water falls from the sky onto roofs, hard surfaces. It picks up any kind of dust and particulates. It picks up any oils. If people forget to pick up after their dogs, all of that stuff gets washed as quickly as possible through hard solutions into catch basins and storm drains, and goes as quickly as possible to the nearest river or stream. When we think about stormwater in a natural environment, it falls on soft ground, it falls on the trees, it falls on different kinds of surfaces that allow typically percolation, allows the cleaning of the water as it gets soaked in. It refills the aquifers, it restores all of the underground waters. And then eventually that either overland or through underland, it goes into a lot of our natural waterways. Thinking a bit bigger, all of these waterways are connected into watersheds. So watersheds are these imaginary lines that divide topography, at which point the water all goes into one system, or it flips back and goes into another system. In New Zealand, they actually define their political boundaries through watershed boundaries, because everything is so connected inside that they recognize as political boundaries, because affecting either groundwater storage or industrialization or how the water is used by different ways affects that whole system. The Grand River, so it's very interesting to learn that you're actually learning about this in studio, but some fun facts about the Grand River watershed. It's the largest watershed in southern Ontario, about the size of PEI, which is pretty huge. It's the home to the Six Nations of the Grand River Territories and Mississaugas of the New Credit First Nation, with about 13,000 residents. About 5% of the land in the watershed, in the Grand River watershed, is taken up by cities and towns. So primarily we're thinking about hard surfaces, roads, buildings, parking lots, a lot of paved surfaces. About 70% of the land is taken up by intense agriculture. So when Jen and I think about what that means, it's largely a monoculture crop. It's stripped in the spring or the fall and kind of brought underground, so there's pretty high runoff rates. There's also some pesticides put on to make sure that they have good crops. There's some some nitrates that are put into the soils. Another fact is that there's been an increase to about 19% of forest cover, whereas around 1900 there was only 5%. So like many places in Northern Ontario, in North America in general, there was the industrialization, a lot of cutting of the forest to make way for farm fields and for different industrial needs. So the total length of all of the rivers and streams together is about 11,000 kilometers, which is pretty amazing. The Grand River watershed supports about 80 species at risk. There's about 90 fish species within the Grand River watershed, which is about half of all the species in Canada. And there's about 250 bird specimens that can be found locally. And of course, the Grand River Conservation Authority monitors the river flows, the reservoir levels, and the water quality. So this is really nice, but why is it important? The Grand River watershed supports about 1 million people. So thinking about the size of PEI, there's about 150,000 people that live in PEI, but 1 million people that live within our watershed. Cambridge draws 80% of the water from 27 wells. So all of that water that we were talking about that gets drawn down into the aquifers and sort of the below ground streams, that's about 80% of the water that Cambridge draws out for us to drink from. 20% is directly from the Grand River. 65% of the water is drawn for domestic use. So those 5% of land that's being used up by cities and towns and different municipalities. So that's quite a huge difference, especially in contrast to agricultural use, which is about the same number. So thinking about stormwater, precipitation, and the quality of the water, this has kind of come full circle and why it's actually very important for us to consider continuously in all of our projects in the way that we think about water and stormwater. So again, thinking about all of that stuff that we spoke about how water falls on our urban environments, about the roofs, about how it falls on hard surfaces. It picks up that particulates, it picks up the oil, it picks up all of the bios that are on the grounds and shuttles it as quickly as possible into the nearest waterways. And also thinking about that stormwater is the biggest contributor to river pollution right now in North America. And of course, GALT. When I was zooming around on Google Earth, which I like to do, and just noticing Mill Creek and how it kind of comes down from Shades Mill and it gets put into this bit of a ditch condition and then it disappears. But cleverly on Google Earth, they actually trace it and how it goes for half a kilometer underground. And a couple weekends ago, I took this photo from the bridge and it comes out right here. And you can see in the Google Earth image, there's effluents that are coming out. But just thinking about how Cambridge evolved, like many North American cities, everyone hugged up to the water because it provided passage, it provided power for the mill industry, it provided clean water for the industrialization, and the edges were hardened up, which helps the water to go faster. On the one side, we see some tree covers, which helps to cool the water, which is also important for water quality. But all of this affects how the rivers move. It affects how the fish species are supported or not, and how everything can recover. In 1974, there was a large flood in Cambridge that caused about $33 million in damage. I'm a couple of years younger, but a friend's mother went into labor and had to get across the bridge to get to the hospital. Amazingly, through this flood, there were no lives lost. So often, Jen and I in our industries, we find that there's positive movements either through monetary losses or loss of lives. And those are kind of the initiatives that make people think differently about how we're planning cities, about how we're installing infrastructure, about how we're affecting the quality of life, and how we can save money. February 2018, again, we saw a lot of ice damming, and Highway 24, even when I was growing up, it was constantly affected by flooding. So stormwater quality and quantity, thinking about sediment load. So the top picture is of Black Creek, a project, Edgeley Pond and Park, which I'm going to be speaking about in a little bit. So there's no quality measurements The water is collected from 54 hectares and dumped directly into a storm pond. There's a really interesting course of study, geomorphology, that deals with how the creeks are designed, about how water flows, about where it hits and where it flows, about how the different stone stratations are made, about how to reinforce banks, and this is a failed bank in Toronto, but how to design rivers more naturally so that they are more sustaining and will take less effort to correct and less disruption to the natural environment. This is a picture of the Toronto Harbour after a large rainfall. And like most cities, Toronto has combined storm and sewer outflows. So after a large storm event, the sanitary and the storm systems mix and get dumped into the harbour. And this is something that the city is trying to correct, but with a 100-year-old plus infrastructure, it takes a while to actually correct it from the top down. So again, thinking about right now how our cities are built with getting the stormwater into hard systems as quickly as possible, about picking up all of the dirt and the grime on the grounds, thinking about two major things. The quantity of the water, so how fast it's shot into the naturalized systems, and the quality of the water, thinking about the debris and the sediment loads and the temperatures. And all of this comes back to the idea about flooding and all of these hard surfaces that are collected in the towns and the cities, and how quickly everyone's trying to get it to those same water bodies as fast as possible, and how that affects the water levels. There's two basic ways of treating stormwater, and there's no one-fit-all solution. And often a combination of both gray and green are sometimes the more successful solutions. But gray systems, which Jen is going to be talking about, one system that we worked on in Toronto in the East Bay front, is dealing with things like oil grit separators, which Jen can talk a bit more about removing the solids and also underground storage. So instead of shooting the water as quickly as possible to natural waterways, to hold back the first flush of water and let it store underground and let it dissipate and seep in. Green systems include things like bioswales, rain garden infiltration galleries. This is an example of a project that we worked on in Banff. So there's a lot of rainfall that happens quickly, and this provided a way of storing the water volume, so dealing with the quantity, and then also dealing with the quality of water, because we were able to have different rocks and plant material to let the water seep in and to treat the water quality as well. Another great way is permeable pavements. And an older way, which still has some success, is stormwater ponds, which I'll be talking about, Edgeley Pond and Park. Just to note as well that the green infrastructure typically takes up more space, where the gray infrastructure can be put into tighter conditions, typically more urban conditions. So again, looking at the gray, the underground storage ideas. There's an oil grit separator going in, so you can see the size of the chambers, which are below grade. At the surface, you'll see two manholes at the surface, about 600 wide, so very low impacts to the public realm, versus the green infrastructure. This is a pond at Durham College, actually, where Jen teaches as well, which dealt with stormwater quantity and quality treatment. And then also a bioswale at Durham College. So the parking lots were sacrificial land. They're future development sites for the university and college. But we directed the water into the bioswales, which held water and treated it because of the natural, the plant material that allowed the infiltration and to take away the sediment loads before getting put into the groundwater or being shuttled to the storm ponds for further treatment. I'm going to hand it over to Jen.
Thank you. So, as Yvonne mentioned, I'm going to talk about the gray solution here, which was part of the massive waterfront redevelopment that's happening in Toronto. I think it's one of the biggest waterfront redevelopment projects in the world. And it's been happening bit by bit over the last, I'd say, 15 years. My firm first came on board when the Pan Am Games were awarded to Toronto, because that really, all of a sudden, there was a very high priority in developing the West Don Lands portion, which is this area, because that's where the Athletics Village was to be constructed. There was big plans for very innovative things happening on the with the buildings, with the streetscape, all that sort of architecture stuff. But we came on board because before they could do any of that, redeveloping the precinct required significant flood protection measures. And before any of the construction could be done, the stormwater systems needed to be implemented. So we were on a fast track process to get that into place. And that kind of led to us then carrying over the same concept to the East Bayfront area, which was on a much more, I would say, a much more reasonable development timescale. But working with Waterfront Toronto was very different as an engineer, because we're used to working with most of our clients. When it's a government client, it's a very prescriptive process and you're really just following design guidelines, whereas here it was sort of really out of the box thinking, because development of this size, I don't think there was really nothing comparable within the City of Toronto. So in many ways we were sort of working with nothing. And our guiding principle was these wet weather flow management guidelines that City of Toronto had brought in. But up until then, it had only really been done on a site-by-site basis. So it's easy to implement a stormwater system for a condo site. When you're talking about 23 hectares, it's a whole different ballgame. It's really a neighborhood-wide solution that needs to be found. So this is the neighborhood where we were looking. It is just east of the CN Tower, would be kind of over there. Redpath Sugar Refinery is here. And you also, this neighborhood, we call it East Bayfront. It comes up in the news a lot at the moment because it is the site of the Sidewalk Labs that you may or may not have heard of. It's an ongoing sort of public debate about how much data should be accessed there by Google, which owns Sidewalk Labs. So that's obviously a very interesting technology, but underneath the surface, which nobody knows about, there's some pretty cool stormwater stuff, which I'm going to talk about. So our guidelines for what we had to do, we knew we had to do something with the stormwater. It can't, now that they've built a flood protection landform, it is all coming to the precinct as opposed to going into the Don River. We had our design guidelines put out to us by the City of Toronto, which has a wet weather flow management document developed in 2006. This is still in many ways it was very forward thinking because not a lot of municipalities were thinking about wet weather flow management at that time, whereas now with climate change it's a much more and more communities have wet weather flow management criteria. For the City of Toronto's, the biggest criteria, well, there's criteria are all of equal importance, but the first one is to remove 80% of the total suspended solids. That gave us some leeway. Originally, thinking about solids removal, you think you need to get to a much more stringent criteria. So that's compared to a wastewater treatment plant, that's a very reasonable suspended solids removal, and that's any of the particulate. It would be, in this case, organic and inorganic. Yvonne mentioned a lot of the organic stuff would be runoff that includes animal waste from dogs. But the inorganic criteria, the inorganic stuff would be grit, sand. A big contributor, especially on roads, is brake dust. You don't think of that using brakes actually generates anything, but it generates a very fine particulate that ends up in the water. And so that would be some of the suspended solids that we're trying to remove. The second criteria, which I can tell you people would think we were crazy when we'd be even entertaining the thought of treating stormwater to a disinfection target, is to get to 100 E. coli per 100 mils for lake discharges during the swimming season. that is what the city is trying to do is every time there's a big rainfall event, all that stuff, all those combined sewers that end up in the lake require beach closures because the E. coli level is just so high, it's dangerous for people to swim. That has also flagged the Toronto waterfront as one of the waterfronts, highest polluted waterfronts. So what their plan there is to require anyone discharging to treat to 100 E. coli during the swimming season, and that is May to end of October. In addition to that, the city in this document gives a theoretical grain size distribution. So the city did extensive testing to figure out what an average stormwater composite sample would be. And that's really important because stormwater is so varied, but they did a really good job of providing us with an average, so then we can actually design stuff. The oil grit separator that Yvonne mentioned earlier, that is all designed. That has a screen in it, and a lot of that screen, the purpose of that screen is to do a significant load of the TSS removal. We're also removing the big junk, like the pop bottles, people talk about bikes coming down the storm sewer, mattresses, obviously all of that would get removed, but the tiny stuff would also get removed. Not all of it, but a significant portion of it. And a key thing with the oil grit separator is that is a static unit. There's no moving parts. It all operates off a swirl process. You're going in on a tangent, and the screen is essentially like a cheese grater turned on its side, so it's got a smooth edge and a rough edge. The water's going around the smooth edge, and that retains the particles, and the water can seep through, but most of the solids stay within that within the inner portion of the screen, and that would be cleaned once every. The ones we've installed are being cleaned once every 6 months, and those two, that sort of concept, again, everything here was. There was no projects. In engineering, unfortunately, a lot of work involves kind of copying other designs that you've done in the last several years, sometimes a little too old. But in this case, we had nothing to go on. It was all kind of trial and error. There was pilot testing involved because really no one else was doing it at this time. And those oil grit separators are the biggest oil grit separators in Canada. The final thing that we got from this document that became our essentially our design Bible was the continuous rainfall data for the design year, and that is based off. It seems like too far back to be using design data, but it's and probably before people were born, from 1991. But that was one of the wettest years on record, and every storm is documented. The millimeters of rain. In 5-minute intervals, so it's a massive data set, and that is what we use to actually size all the equipment. And even to this day, it's still, I keep looking to see when they're going to update it, but they're still using 1991 because that really was the wettest year on average. We've definitely had some storms that have exceeded storms, but in terms of volume of rain per year, 1991 so far is the record. So. That was all our hard engineering requirements. Some other requirements were that were especially in wastewater plants. Real estate is not usually a problem for us. We're usually away from the nearest house, might be 200 meters away. Whereas here we were dealing with a very obviously in this picture. It looks like a empty place, but the plan was to have condominiums, very residential mixed use. So real estate was at a premium, and it's also some of the most expensive real estate. I think it's fair to say it's some of the most expensive real estate in Canada at the moment. So taking up space for an open air stormwater tank would be kind of career suicide. There was also, when we came on board, the public realm side of things, I would say, had been fairly well developed. And there was a water's edge park and a very high along here, and a very high quality streetscape that was not to be impacted, have as least impact as possible on that, because obviously this is a new sort of a premier neighborhood that we don't really want to be showing off our wastewater treatment facilities in. So that was a very large design constraint. I just want to add, originally the plan was to have a very long settling tank along the wall all the way across, and that would be hidden in the lake. But and that was the plan for a few, I think, at least for the first year. But the cost of operating that turned out to be prohibitive. And given what we had done over in this area with a similar concept of capturing and treating the stormwater, a tank was proposed for this area. The tank, the actual design consists of two parts. There's the tank, which captures the flow, and we're capturing up to the 2-year storm, but we're not treating the 2-year storm. So the tank is designed to capture most of the water. Obviously, we're not going to capture all of it unless we build a massive tank. So the tank is designed with an overflow. So there will be events that overflow. We're not going to capture everything, but we are going to hit that, removing 80% of the total suspended solids, the TSS, because most of what everything we capture will get treated, and that is going to be treated in. It gets pumped following this blue line over to a ballasted flocculation facility, which we call the BFF. Once it's treated, it will then be discharged. At one point, we were looking at putting in the ballasted flocculation facility within the precinct. I think at one point it was looking at it was going to be next to a Starbucks and a daycare center, just feasible, but very challenging to make everyone happy. And probably a lot of future complaints would have happened just because things happen, like noise and unscheduled maintenance requiring road shutdowns, and deliveries might not be able to happen as such. So the design team quickly realized that because they were already building a ballasted flocculation facility to treat the West on land, which again was fast-tracked for the Pan Am Games, it would make much more sense to simply pump. Obviously, it's going to be more expensive because of bigger pumps pumping a longer way. But when all is said and done, it would make much more sense to pump everything over to the ballasted flocculation facility rather than build an identical facility in the new precinct. So that was done, and that ballasted flocculation was then upsized even further to incorporate another future precinct. Oops. Within the ballasted flocculation facility, and this is essentially a mini wastewater treatment plant. It's very similar technology to what you see in a municipal wastewater treatment plant. We've got the initial oil grit separator, which takes out a lot of the big, well, it cleans out all the big debris and takes a lot out of the suspended solids, but there still is suspended solids that are going to get through. How we're dealing with that is a treatment called ballasted flocculation. This is comparable to, you probably haven't really spent much time thinking about wastewater treatment plants, but you often see really big circular tanks. Those are clarifiers, and that's where they're doing a settling process. You're usually adding a bit of chemical that helps everything to settle. We don't have the luxury of the footprint that you need for those. In this case, we are adding essentially a sand and glue mixture that will glue onto any of the particles. Everything will rapidly settle out because you're adding so much chemical. There's the first two are mixing chambers, and then the settling happens here, and you get very clean water. So it's similar to it's the same process as clarification. It's more expensive because you're having to add more chemicals, but you're able to achieve the same treatment with a very small footprint. And in this case, that is what we needed. After the ballasted flocculation, we do our disinfection, and again, that's during the swimming season only, and that is where the water is treated by UV light. I can tell you when we first started looking at design for this, and you talk to the main UV supplier is based out of London, Ontario, called Trojan Technologies. They looked at you like you're crazy. What are you treating stormwater for? No one cares. Now all of a sudden, 7 years later, it's much more common. So that's just to drive home the point is this was really Waterfront Toronto. We're really a leader in pushing this kind of technology, or pushing the treatment requirements here. There was a need to control the water flow. Again, the storms you're going to get a lot of little storms, which you don't even want to bother turning your pump on for because you're going to waste energy, and you're going to get some huge storms. The main purpose of the tank, and this is these were concepts that we didn't end up going with, but the main purpose of that tank, and it's a very large tank, 2,000 cubic meters, is to attenuate the storm. So the big storms, the little storms, they all gather in the tank, and those pumps are only going to turn on when it makes sense. You don't want to pump 10 liters of water over for treatment. You're just going to waste a ton of energy. That tank does not even turn on. The pumps don't even turn on and start pumping until you get to a level where you'll be running your equipment for at least a couple of hours. And then again, these tanks have overflows. So the giant storms, they're going to take as much water as they can, and then the rest will just go to the lake. And this was the in the dock solution, the beyond the dock wall solution that was originally proposed. All of these options, this was kind of the one I would say we proceeded a fairly good distance down the design timeline. But ultimately, all of these options were overruled, partially because the rectangular tank, which we spent a fair amount of time designing, and we came up with a way to make it feasible. There was tiebacks from the dock wall, a lot of things that had to be taken into account. But again, from our perspective, we're not used to having to put covers on tanks. In this case, obviously, everything had to be covered. You don't want people falling in. But you also had a lot of hatches were required, and I feel like that's when I really met Yvonne, because we would have so many calls about these hatches, and I mean, it was like we needed hatches for the pumps, we needed hatches for the confined space entries, we needed hatches for flushing gates, we needed, maintenance want to be able to visually see the bottom of the tank, because inevitably you're going to need to do cleanouts with power washers and stuff. And you preferably want to do that from above ground, because confined space entries are very, very, maintenance people want to avoid those at all costs. So we ended up with all these hatches, which I remember we were just fine to just drop them in wherever. And then I think one particular call with Yvonne, she mentioned silvacells, which I had never heard of, soil cells. And all of a sudden, the amount of hatches that we were putting in was starting to impact the trees. So it was really it was a real eye-opener for me of like, oh, we can't just do whatever we want. We have to. They were the prime consultant, but also like the public realm here is of utmost importance, and we really were struggling to fit in what we needed within the public realm requirements. So this was the design that we settled on. But for many reasons, we ended up moving forward with a different design. Other than the hatches, there was also some land issues with Toronto Parks own this land, and there's so many different silos of people working within the City of Toronto. You would think that because they're all working for the City of Toronto, there's not so many turf issues, but there actually is a lot. And Toronto Parks didn't want to have to sign over some of the land to Toronto Water. Like it sounds kind of ridiculous talking about it, but it really is like separate companies. Another issue that came up was the mechanical room. Like for a tank, we've got pumps in there, 600 volt pumps. So you need motor control centers. All of that would have been in here and in here. We looked at putting an electrical room underground below the water table, which again took a lot of convincing that for our electrical people to even look at it, because they thought, no, you're crazy. Like why why would anyone put electrical cabinets where there's a flood area? Just put them in the building. And you're trying to explain to these guys, no, you can't. Like, that is, I don't know how many thousands of dollars per square foot, but like, we can't give you an electrical room. You have to put it underground. Putting it underground then requires hatches and stairways and anyway, so I could go on, but I won't. What we ended on was a really awesome solution, which was putting the tank within the roadway. You can see the soil cells are all over here. They're not impacted at all. Our tank is much deeper, which means we actually have to pay more money to pump the water out, but it's a sacrifice that is worth making. There's good visual. You can see the bottom of the tank from the hatches. You've got the one hatch for the pumps. You've got a much smaller footprint, which means it's much easier to clean the bottom of the tank. The pumps can actually do most of the cleaning just because they've got jets on them, whereas before we had to have separate flushing, which required very large flushing gates, so those get removed. And we're not interfering with the dock wall reinforcing or the tiebacks. And so everything fit within a very tight 21-meter right-of-way. The construction costs were actually cheaper here because once you get into the bedrock, it's actually, people like, at first thought you think it's going to be more expensive because you're going that much deeper, but it's not actually. There was an economic benefit. And the other thing, which will tie us back to Yvonne, is that there was no tree loss because all of the trees are undisturbed. We're within the right of way. This is another photo or a rendering of what it looks like. You can see there's one hatch within the sidewalk. And there's one control panel, but it's pretty amazing that we were able to make it fit. It's very tight. I think it's like inches or millimeters to the property line, but it is within the right-of-way. These are some construction photos. This is the main tank getting constructed. To give you an idea of size here. The Silva cells. This is what the promenade looks like now. So again, like, one thing that kept coming up is like, how are we going to get maintenance trucks if we had the tank in the promenade here? Having to get maintenance trucks in to pull out those pumps on a regular basis. I feel like no one was saying it, but those trees might have been some collateral damage. Whereas now the trucks are all on the road, so it's not a problem. And again, now this is the built project. Unfortunately, I know architects always get to look at their jobs. Unfortunately, when I tell my kids whenever I'm down there about this, no one's ever going to believe me that there's a huge tank under there. But there is. And that is, I'll turn it back to Yvonne for the green side of things.
So the second project that we'll talk about today is Edgeley Pond and Park, which is in the city of Vaughan. It's a 7.5 hectare site. So this is sort of the green side of how we deal with stormwater. And again, no one solution fits all. So this is what the right solution was for this project. Black Creek flows through the site. There is 767 hectares of subwatershed that actually flows through this site. There's also an additional 54 hectares of urban water that flows into the site totally untreated. So all of the oil, the grit, the gas spills, everything just comes straight into the site. This site was deemed the #1 hit list item for the city of Vaughan to tackle because of property damage. So again, thinking about the two things that usually motivate people is cost, property damage cost, and also saving lives. The area around here is the new Vaughan Metropolitan Centre, the VMC. The last subway stop, the newest subway stop, is the VMC subway stop, which is 1 block away from here. This is going to be the home for 7,000 new people. So there's going to be massive condo development, mixed use, sort of a new commercial center right around here. And this is the only piece of land that's actually owned by the City of Vaughan as well. So they wanted to make the most of it. These are some existing photos of what the site looks like right now. So we can see Black Creek. It was dug out in the early 80s, and literally a black hoe just kind of dug out the creek bed form. There's the stormwater outflows for the untreated storm. These ponds used to be dry ponds, but because they're so silted up, they were never maintained in over 30 years. They're now wet ponds. This is the existing control structure. So all of that 767 hectares of subwatershed that flows down, this is basically the dam that holds the water back and floods this entire area, which is now spilling over onto Highway 7 and Jane and causing property damage and significant infrastructure damage. You'll also notice here, this is where the fish have to go through. But unfortunately, there's a foot difference between where Black Creek hits this element, so it's blocking fish passage. So what happened was the August 2005 storm really initiated and caused the City of Vaughan to think hard about the stormwater management, about precipitation, about all these things that we're talking about, and how to move forward in a cost-effective way. They did many series of environmental assessments, which take a look at the engineering and the social issues of different kinds of design solutions, what's going to be best. The City of Vaughan is also very clever because they figured out a financial strategy of how to actually pay for this and maintain it. So it's not enough just to pay for the large construction cost, that big number, but then how is it maintained over the life of the project and how it affects people, because everything, a lot of the projects that we build need some kind of maintenance to keep, for it to perform at the level that we want it to perform at. This was the indicative plan that was developed for the costing to be done. One thing to note, actually a couple things, this blob here ended up being a clump of 200-year-old oak trees, which was from the European founding of the village of Edgeley, which, because the environmental assessments were done quickly, they didn't actually discover and propose to wipe out. Black Creek was sent in the sinuous course, which is good because the length is long, which is better for a creek system to have a longer length. This water body here was sold as, I think they called it a lake. So all of the politicians were thinking, awesome, I can go canoeing, I can go windsurfing on this, I can go fishing, but what they failed to interpret from all of the reports is that the water would actually be only about a foot deep, which meant in the summertime it would be a mud mat. So we had the job of talking to our clients and kind of informing them and reading all the reports that this was actually going to be the built product, which made everyone think, oh crap, we can't go canoeing on here. So we had to kind of change ideas about what this project would be and really hone down on what we really wanted to do with this land. We spent about a year talking with the public, talking with the stakeholders, and kind of understanding what Edgeley Pond and Park wanted to be. We knew that the stormwater quality and quantity were paramount and how we were going to deal with that. We knew that we had nowhere else to go. This was the only city-owned land. We knew what our budget was, which was about $20 million. We knew that we had to phase the land because right now Maple Creek stops here. This was a future development, so we thought of it in two phases. And then what ended up evolving was a third phase because this is a stratified park. So it's a publicly owned park over top of a private parking garage, which creates some headaches. But it's super fun because we had to think also about the different stratus in this park. We had to think this was going to flood. We're not going to be stopping 767 hectares of subwatershed flowing into this pond. We had to deal with flooding. But we also could deal with all of the land that was above the floodplain, and we could create activities on it and really make this a public park for all of those new residents and all of the people that would be working in the area. So we worked through some different concepts, and as always, the end solution was kind of a smash up of all of those different elements, and people told us what they liked, what they didn't like, where we were hitting the design correctly and where we were missing it. There were a lot of first-time condo owners, which were downsizing couples that said, you know what, we want to head out at 7 o'clock in the morning and we want to walk laps here. We're like, okay, so we're going to give you some pathways. And so we created a network of pathways, which are also maintenance pathways to service the area. We have a lot of different ways that you can enter the site from along Jane Street. We have an urban plaza at the corner of Jane and Highway 7, which we had to cover over because we couldn't create slopes that created any kind of natural environment for Black Creek to flow through. And I'll talk to you a perspective on how we kind of dealt with informing the public that Black Creek is actually underneath. We created a future bridge here. This is actually something that's going to be happening sooner than later, which is really amazing. It's a pedestrian bridge that crosses through this ecologically sensitive island, so it controls public access so people can't get onto the island, but it cuts through and allows all these people that are going to be living in these new condo towers to get to the TTC stop right over there. So you can imagine your lovely walk to your commute to your TTC, going across this bridge through this 200-year-old oak grove to get onto the TTC. We needed to think about a lot of different engineering criteria. One very basic thing, which is a lot more common now, is the oil grit separators, which Jen was talking about. So all of those 54 hectares of urban water that was flowing in, we treated with the oil grit separators, which again takes out about 80% of the total suspended solids, which is just a clear win. It's already part of their maintenance programming to clean out, so it was a no-brainer. We worked with a geomorphologist to design Black Creek. So he did a lot of studies about how water enters the site, the speed of the water, the kinds of fish that we want to see in here, because we're going to be removing the fish barriers, and what kind of ecology we're going to be supporting on the edges of the water. So we also worked with an ecologist with a different plant material and kind of creating a larger designed ecosystem. Again, thinking about this is actually a storm pond. It's an urban storm pond. So we knew that there was going to be the seasonal fluctuations which would impact the pathways where people are walking. We knew that in large storm events that it would impact even more. We knew, so there was, again, talking about politics, there's a whole bunch of different ownerships. One of the largest roadblocks that we met was York Region owns a culvert that goes underneath Highway 7, which basically is creating a bathtub effect, and we need to have a larger culvert to manage a regional storm, which is the largest sort of measured and designed storm. They said, that's very nice. Either you give us $20 million or you're going to have to wait 20 years. And so this has gone back and forth. Politically, the Toronto Region Conservation Authority, the local conservation authority, has spoken to them, but unfortunately it doesn't fit in their budget. So we had to design a system that we knew is still going to flood the intersection of Jane and Highway 7, which is unfortunate. The good news is that it's going to flood much less frequently because we have put in more design controls. We have a larger volume for water storage. We're going to be treating the water quality as well. Once York Region puts in that new culvert, we can actually manage a regional storm within the pond, and there's no spilling whatsoever. So that's our ultimate goal, and which we had to communicate to stakeholders in the public, which was really difficult to talk around. And then just thinking about the pathways and how everything would flood. And in the larger storm events, the pedestrian bridge would not be affected. And again, all of the programmed areas are going to be outside of the regional storm line. So what we thought about, obviously for public safety, are all the different points that you can enter and exit the site. So all of these white dots with the blue around them are ways that you can enter and exit. We thought about all of the different developments around the site and how people are going to be using it, about controlling and predicting the flood storm events. We have iconographic flood danger signage, so instead of using words, we're using symbols so that anyone from any age can kind of understand what's going to be happening and some of the dangers. And this park has it all. It has dog parks, adult exercise equipment, We're creating aquatic and terrestrial habitats, those walking circles that I mentioned. The active uses are all outside of the floodplain, and a lot of the passive uses, such as the walking circuits, are within the floodplain and can be affected. We thought about the materials we're using. We worked with the TRCA. We're not using any gabion baskets because a lot of stuff gets caught in it and it's really hard to maintain. So we have a lot of either stone or flat concrete surfaces so that it can be cleaned quickly. The splash pad and skating loop and such are on this strata park here, again outside of the floodplain. This is a perspective that we did looking at one of the outfalls and the pathway connections, those 200-year-old red oaks in the background, and some of the proposed towers that are going to be on the west side of the park. This is a perspective thinking about art, because this is a really amazing opportunity for art, especially within the floodplain, because it can be inundated and designed. All of the pathways and the access in and out of the pond area are all accessible, so under 5% slopes, accessible 8 to 80. So thinking about all the people that are going to be using the park. And this is an image of the pedestrian bridge that's crossing over that island. And then coming back to that urban plaza, because we can't actually expose Black Creek, we are putting in a proposed water feature that actually links up to the adjacent development stormwater tank in their parking garage. That would showcase stormwater in more of a naturalized system, have some signage that actually says Black Creek is underneath your feet, and just to highlight the fact that it's there. So now just thinking about the two projects that we spoke about stormwater, precipitation, and all of the different ways that rainwater affects us. We both talked about our clients that were really champions for stormwater management, for thinking about the quality and the quantity. No one solution fits all. So again, coming back to working in the right team with all of the different members that provide different perspectives, different needs for the design to make it work. And also the different scales, whether it's a bioswale, whether it's a storm pond, whether it's an oil grit separator. There's different ways of affecting the water quality and quantity. And yeah, thank you very much for your time.